Use Lagrange multipliers to find the extreme values of the function under the given constraints. So, we have 2 constraints on this one. Yay. All right, so what are we going to do? We're going to find del. Okay, so what's the method, by the way, when you have 2 constraints? You set del f equal to what? Lambda del g plus mu del h. So with the understanding that we're going to call, technically, I suppose we're going to set it equal to 0. Whoops. And call this guy g, right? Y minus z minus 1g, or we could move it to the other side, doesn't matter. And then set this guy equal to 0 and call the left-hand side h. And it doesn't make a difference in this one setting it equal to 0 because the thing on the other side is a constant, but it's a good habit to get into. All right. And then that equation, you solve the resulting system of equations that you get from that equation with the del f equals lambda del g plus mu del h. And those are your critical points. So let's try that. What do we get for del f? That's not too bad, right? 2xi, 2yj plus 2zk. What do we get for just del g? So yeah, we got to be careful here. 0 for the I component, right? And then just j. I'm going to line things up. You take the derivative of this guy with y minus z minus 1 with respect to y. That's the g sub y part of del g, right? And you just get 1, don't you? So just j, 1j or just j. Plus what? Or actually, how do you want to write it? Take the derivative with respect to z for the third component. What do you get? So minus k is kind of what I'm after there. Does that make sense? You're shaking your head. How come, George?
Oh, no, I got it.
Okay. Thought you didn't believe me. You're just, why do I have to do this? I understand that. I understand that attitude. Okay. Del h. Oh, by the way, if you want, you can multiply through by lambda anytime you want. So lambda, 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 right? And then what's del h going to be? So 2xi, and leave a little space for your mu. And then we're looking at this guy, right? So plus what? 2y j, and then there's going to be a 0k component, right? So you don't need to write that down. Does that make sense to you? Okay, multiply through by your mu, and that's what you have. Does everybody buy that? Okay. Then to create our system of equations, let me shrink some things down here. Get rid of some stuff. Leave as much room as I can. Okay. So then set corresponding components equal from this equation, right? So what do you get for 2x? What does 2x equal? So just 2 mu x, right? Does everybody believe that? Okay, and then what does the 2y, that's the 2y from the del f, what does that equal? Lambda plus 2 mu y? Okay, so 2y equals lambda plus 2 mu y. Does everybody see where that comes from? Okay, and then what? 2z equals what? Negative lambda. And is that it? Well, that's it for that one, though, right? And then you're saying write down your constraint equations because that's part of your system, right? Okay, so y minus z equals 1. and then x squared plus y squared equals 1, using the original form of the constraints. So here's your system of equations. Does everybody buy that? Okay, so take a second. Don't just start saying this equals this. Look at all of those equations. Which one might be reasonably easy to deal with? 2x equals 2 mu x? I like that idea. So how do you have to deal with it? Well, what can you get rid of first of all? Not even worry. Not even give a second thought to. Divide out those 2's, right? And then that gives you x equals mu times x, and then if you get everything on the same side, you have what? X minus mu x equals 0. If I subtract mu times x from both sides. Now here, I do have to worry. I'm not just going to divide out x, am I? I don't see a reason that allows me to do that, to assume x is not. You can divide out x if you can assume x is not 0. I don't see a reason for that assumption, so I'm going to factor out x instead. Does that make sense? Okay, so I'm going to factor out the x, and then what's left? 1 minus mu. That gives me 2 possibilities, 2 cases. I'm going to exhaust the possibility in both cases, and I often get the question, how do I know I've exhausted all the cases? Well, this gives you 2 cases, either x equals 0 or mu equals 1, right? You follow those 2 clues and exhaust all the possibilities with those 2 things being true, one or the other of those 2 things being true, either x equals 0 or mu equals 1, and you're done if you exhaust all the possibilities in the other equations. Okay, that's how you know you're done. So we get 2 cases, either x equals 0, or if you set 1 minus mu equal to 0, you get mu equals 1. Does everybody see where these 2 cases come from? Well, I like x equals 0. That's pretty easy to follow, I think, because I could use, for the bottom 2 equations, well, really the bottom equation, and then the bottom equation, if I set x equal to 0, that gets me possibilities for y, right? And then I can use the second to last equation to get my z value based on those possible y values that I get. Does that make sense? Okay. So let's look at the case. And again, I'm going to keep this on one screen as long as possible, so I have to shrink this down. So let's go kind of over here and look at the case where x equals 0. From the bottom equation, that gives me what? Y squared equals 1, which gives me 2 possibilities for y. What are they? Y equals plus or minus 1. So then I want to look, I've got 2 points I want to look at. 0, 2, but they're not three coordinate points. They're 2 coordinate points, and then I'll get the third coordinate by looking at these 2 possibilities. So 0 comma negative 1, 0 comma positive 1, right? Or you don't have to write them as points. You could say x equals 0 and y equals negative 1. That's one possibility. Or x equals 0 and y equals positive 1. You got to look at both of those to get the correct z value, right? Okay, so under this situation, when x equals 0 and y equals negative 1, we're going to look at this third equation to get, or this second to last equation rather, to get our z value. So, okay, so just plugging in negative 1, I get negative 1 minus z equals 1. So what does z equal?
Negative 2.
So z equals, yes, negative 2. So what's the critical point that we get then? Adding
0, positive 1, negative 2.
0, negative 1, right?
Yeah.
Negative 1, negative 2. Okay, so that's one critical value. And then let's look at this one. So we plug in positive 1, this same second to last equation for y, and we get 1 minus z equals 1, or z equals 0. Does everybody see that? So what's the critical point there? 0, 1, 0. Okay, so 2 critical points from this case. Call it case 1 where x equals 0. Does everybody believe that? Let's look at the other case. Now, under the case where x equals 0, is there anything else that could happen? No, because those last two equations have to be satisfied. The only points that satisfy those last two equations are the two critical points we found. So we know we're done with that case. So the other case we said is mu equals 1. So I'll kind of break it up here. Mu equals 1. And if you like, you could label it case 2, although I'm not going to be particular if you do or not. So mu equals 1. Well, there's some equations we haven't taken advantage of yet, have we? So I'm looking at this second equation. What do I get if I just plug in mu equals 1? Let's just write that down. 2y equals lambda plus 2y. So does everybody agree with that? So 2y equals lambda plus 2 mu y. Well, mu is 1, so 2y. So what does lambda equal in that case? 0. How does that help? Okay, so we haven't taken advantage of this equation yet, right? That means 2z equals 0 or just z equals 0. Right? How does that help? Go to the second to last equation once again. This second to last equation right here, we can get y from. Okay, so y minus 0 equals 1 when z equals 0. So y equals 1. Okay, how does that help? Okay, the last one. Then what do we get? When y equals 1, x squared plus 1 squared, which is 1 equals 1, or x squared equals 0, or x equals 0. So that is the critical point. Which critical point is that? 0, 1, 0? Yeah, but we didn't know that ahead of time, did we? Yeah. Have we exhausted all the possibilities? So which two critical points are we going to look at? Just the only two unique ones we have, right? Now, is there a reason to make a table for this? I don't think so. So we're going to take f of 0, -1, -2, and see what that gets us. Oh, okay, so what happens when I plug in to the original function, 0 for x, -1 for y, and 2 for z? I get 0 plus 1 plus 4 is 5. Okay. Move that right there. Okay, and then let's plug in the other one. F of 0, 1, 0. That's just going to be what? 1 squared, which is 1. Okay, so that means, assuming that these extrema exist, this 1 will be your absolute minimum on the constraint. This 5 will be your absolute maximum. And the extrema do exist, I guarantee you. I guarantee it. I feel like I'm selling you a car.